Right. Now let's look at question number 11, part A of the applied paper. So this is the VT graph question. So let's see how to do this. So let's see a car P that begins its journey from rest. Right. It starts from rest on a straight road. So let's draw a rough diagram with the details. Car P starts from rest. So initial speed is 0. Right. And it starts from point O. Right. This point is O at time t equals 0. So this time is t equals 0. Right. Then what? Moves with constant acceleration f for 5 seconds. Right. So this will go with acceleration f in that direction, and will achieve some speed at that point. Let's say that speed is v. We will find that later on. And it then moves with that constant speed for another 5 seconds. So t equal 10 seconds. In this section, acceleration is 0, constant speed. Then what happens? Decelerates at a constant deceleration of f and comes to rest at point A. Right. So sometime, we don't know what time is this. It will come to point A and speed will become 0. Here acceleration or deceleration is f, so acceleration is minus f. Right. We have written up to that. Now let's see what is left. So rest. Then the car P changes its direction instantly and returns towards O with the same constant acceleration f. Right. So now car P starts moving in this direction with what? Minus f acceleration. Right. Okay. So that is for car P. Right. Then what else is given? Another car Q that begins its journey with an initial speed 10f from point O at time 10 seconds. Right. So this is car Q. His initial speed or car's initial speed is 10f, and that car starts from O also, and it starts at 10 seconds, time 10 seconds, right? And it is doing what? It is moving towards car P. So car P is coming here in this way, car Q is going in this way, right? So car P with a constant deceleration. So this one is acceleration, then will be minus f because deceleration is f, right? In that direction, right? Right. Then there's another data given. It is given the distance between P and Q when P comes to rest at A is 125 meters, right? We have to use that also. We'll see how to use that. Sketch the velocity time graphs for the motions of P and Q from t equals 0 until they meet in the same diagram, right? So let's first draw P's motion, right? So time velocity, right? So starts with 0 and goes to 5 seconds with acceleration f. So tan theta. Then achieve some speed, no? The speed v. Let's figure that out. We know what tan theta is f. In that section, acceleration is f. In this section, acceleration is f. So tan theta is f. So tan theta is v over 5. So v is 5f, right? So the speed is 5f. So with that same speed, car p goes with 5 seconds until 10 seconds. So right after that, he will decelerate with the acceleration minus f, right? So that is point a. At point a, velocity becomes again 0, and because this is also tan theta, no? Sorry, theta angle is theta, no? Because why? Acceleration and deceleration both are f. So from symmetry, it is clear, if this is 5 seconds, this has to be 5 seconds. So then this time has to be 15 seconds, right? Right. So we have drawn car piece graph up to this point. Then what are they saying? Then reverse says the direction, changes direction and goes in the other direction with the same acceleration f, right? So that means you are going reversing, means velocity becomes negative, so some distance it will go down, right? So that is car p. So let's label this as car p, right? Then let's look at car q. Car q starts with 10 f speed at 10 seconds, right? Let's use a different color. So at 10 seconds and speed is 10f, right? And what happens, it also goes with deceleration f or acceleration minus f. So it is going to be parallel to this black line because same deceleration. This also has the same deceleration f. Black line has also the same deceleration f, right? So then due to that, we know what it has to be like this, right? So let's say at this point they meet. So this time, let's say capital T. We need to find this capital T, this amount, right? Okay. So this is car Q. So theta, no? So in 5 seconds, its speed has to go from 10f to 5f. So this is from 10 to 15, no? So that is why these 2 points are in the same level, right? These 2 points are in the same level because same deceleration. So in 5 seconds, speed will reduce by 5f. So 10f minus 5f is 5f, right? So those are the correct velocity time graphs for car p and car q, right? So that part is done. Now we have to show what f is 10, right? So for that we have to use this. What is this? It is given that the distance between P and Q when P comes to rest at A. So that this time also we found this time is 15 seconds. 15, right? P comes to rest at 15 seconds, right? And A is 125 meters. So distance between P and Q when P comes to rest at A is 125 meters. So that means what? So then let me label this O, A, B, C, D, E, F, G. Right. So OABC is the distance traveled by car P from O to A. So distance traveled by car P from O to A is given by OABC area. Right. Then that area is how much? That area is half into height is 5f into the parallel sides. Parallel sides are 15 seconds plus 5. So this is 50f. Right. So that is the distance traveled by car P from O to A. Then from 10 seconds to 15 seconds, car Q has traveled some distance also. Right. So we'll figure out that distance next. From 10 seconds to 15 seconds, car Q distance. How much this car Q has traveled. So that is given by what? That is given by H. Let's say this is H. That is given by D. This area DECH. That trapezium. DECH. So let's figure out that area. DECH area. So then height is what? Height is CH, which is 5. The parallel lengths are 10f and 5f. So we have half parallel sides 10f plus 5f. Height is 5. So then this will become 15f, 75f over 2. Right. Okay. Right. Okay. Then remember this is car P times 0 seconds O. This is car P at time 15 seconds. Right. So we have figured out this length is what? 50f, and car Q started from 10 seconds, and we have the distance between Q and P. P is at A now. Q is now at some point here. 10 seconds to 15 seconds it has traveled. 75f over 2 distance. Then the difference between these two distance is what is given to us. 125 meters is that difference. So we can use that. So 125 is equal to what? 50f minus 75f over 2. So that is what? Multiply by 2, 250, 100f minus 75f, or 250 is equal to 25f, then f is equal to 10, right? So that is shown, f is 10, right? So that part is done. Then we have to do what? Cars P and Q meet at t equals 17.5 seconds, right? Right. Again, we have going to use that 125 meters. So now when it is at 15 seconds, when 15 seconds, remember car P is at A, car P is at A and car Q is at this point, and the difference is what? 125 meters. And now P is traveling in this direction, Q is traveling in this direction. So when they meet up, when you add the distance together, how much P traveled and how much Q traveled, those two together should be equal to what? 125 meters. So what is that in the graph? So CEF GH I CEFI. So that is this amount. That is what? That is car Q's area or car Q's distance travel from 15 seconds to until they meet. So let's write that down. Area CE area CEFI CEFI plus we have to find the area traveled by car P. Together they will equal to 125 if they are meeting. So CIG, that gives you what? Black area, no? Black curve is the car P. So CIG triangle area is car P area. CIG area both together has to be equal to 125, right? So now let's write them. So what is CEFI? Okay, right. So both areas together is what? So if I just combine them, that is going to be CEFG area. That is clear, no? CEFI is the area or the distance traveled by car Q. Then CIG is the distance traveled by car P until they meet after 15 seconds. So then the total area is given by CEFG, that parallelogram CEF. So these two together is equal to CEFG area. So that is equal to 125. So then what is the area of a parallelogram? Base into height. Base is what? Base is phi f, height is capital T, which we want to find. Phi ft, phi ft is equal to 125, and so this is ft is equal to 25, and f we found to be 10. So capital T is 2.5 5 seconds, then what do we want to show? Cars P and Q meet at 17.5 seconds, correct? No, up to here 15 seconds, then when they meet it is 15 plus t, so 17.5 seconds. So cars P and Q meet at t plus 15 seconds, that is equal to 17.5 seconds, right? So that is the answer for part A of question number 11. Next we will do part B of question number 11.